Hi, Owls. Welcome to week 7 for ACT Science Prep. This week, we will be focusing on tables. First, we'll talk about strategy for attacking questions that have tables in them, and then we will do one practice passage that has a lot of tables. All right, tables on the Science ACT. These show up in the two passages that have figures in the data representation passage and the research summary passages. Obviously, they're not in the third type, the conflicting viewpoints that's only text. Tables are used for organizing information and data. So usually you'll see lots of rows and columns, lots of big tables on the ACT Science. They are very popular in the ACT Science. Almost all of these passages mentioned in the first bullet point will have at least one table. Okay, table strategy. What should you do if you see tables? Number one, this is just a reminder, we say this in all of our videos, go straight to the questions. Don't waste time reading those paragraphs. It's written at a college or even higher level. You don't need to know that information to do well on the questions. Skip those paragraphs and go straight to the questions. Okay, second, if the question asks about table 1, typically they'll tell you which table to look at. Find which other questions also go with that table and do them all at once to save time. So you're not flipping back and forth between different tables. You'll be more efficient and you'll get less confused that way. So group your questions. All right, third strategy. When you look at a table, write all over the table, right? The ACT gets recycled after you use it and turn it in. It is your paper ACT, write all over it. Circle the titles. Look at what keywords are in the titles. Maybe this graph is about temperature. This graph is about pressure. What is happening in this table? Look at trends. As you go down a column or across on a row, are the numbers getting bigger or smaller? I might write to myself on the side really quickly, increasing, decreasing, so that when you're looking at it quickly, you can see what's happening in the table. And then also this last bullet point, are there columns within columns? So maybe the big title for the table, a smaller heading, and then two parts underneath that heading. Are they splitting it into smaller columns? Why are they splitting it? Maybe this column is for this temperature, this column's for this temperature, or for this type of molecule and this type of molecule. So there's usually a reason why they're breaking it down into smaller columns, and that'll help you understand the table better if you can figure out why did they break it down. Next, this is another annotation strategy. Try to make tables easier to read for yourself, especially when you're stressed and panicking. If you can shade maybe every other or the ones that go together. These are all for this temperature. These are all for this temperature. Shade them, draw squiggles or symbols. Find a way to make the table easier on your eyes. Especially I do this if it's a big table and there's a lot of information. And you can break it down, even just making the lines between sections of the table darker so it's easier to read and you don't get lost looking at it. So really draw all over your tables and all of your graphs and figures. Okay, that's your strategy, pretty simple. What I want you to do now is open up the link in the video description, click on the Jamboard activity, and there's one practice passage that's very table heavy. I want you to try the practice passage, and then we will check answers after 5 minutes. Again, the link is in the video description for this Jamboard activity. All right, you have 5 minutes. I will start the timer now. All right, it has been 5 minutes. Here are the practice passage answers. So check your answers, see how you did. If you would like typed answer descriptions, they are in that same drive that's linked in the video description under answer key document. And I typed out why each one is correct. We are going to go over these together as well right now. So I'll open my own Jamboard. Okay, so here is the practice passage that you were working with. Again, the first thing I'm going to do is not read this paragraph. It's just going to waste my time. I probably wouldn't understand it anyway, because remember, they usually are using really high level science things that you probably haven't seen. Looking at these two tables, one thing I might do right off the bat is I might highlight or circle their titles. We've got table 1 and table 2. That way I know what I'm looking for when a question says table 1 or table 2. And I'm looking at, okay, what's the difference between these? They look like very similar tables. And I noticed right off the bat, one thing that's different here is that table 1 is looking at pressure and table 2 is looking at temperature. Okay, everything else seems to be the same gases. They're looking at volume for both, but I noticed this one's looking at pressure and this one's looking at temperature. So that might be important as we go through the questions. All right, straight to the questions. Here we go. Number 1 says based on table 1. So I know I'm looking at table 1. For hydrogen H2, here's H2, at 273 Kelvin, 273 Kelvin. Okay, the whole thing's 273 Kelvin, so that doesn't really matter. The value of the difference between the volume at 5 atmospheres and the volume at 10 atmospheres. So they're just asking what's the difference. The way they ask it's weird, what's the absolute value, but that just means what is the difference between the volume at this pressure and the volume at this pressure. Okay, let's find the two pressures. At 5 atmospheres, there's 5, the pressure is 4.496, and at 10 atmospheres, the pressure is 2.256. What's the difference? Now, on Science ACT, you do not get a calculator, and I think it would be a waste of time to find the exact difference between these two because they're not giving us super long decimal answers here. So what's the approximate difference between these? Looks like about 2. Okay, which one's about 2? That would be B. So your answer for number 1 is B. All right, moving on. If we want to question group, if you found that that's a strategy that works well for you, let's find which other ones also go with table 1 since we started on table 1. 2 is about table 2, so we'll come back later. 3 is about both, so you'd save that for the end. 4 is about table 2, so we'll come back later. 5 is about table 1. Let's do number 5 now. So I find it helps me to do all of the ones that go together with the same table so that I'm not skipping around on the tables. All right, 5. In a gas sample, collisions between gas particles are common. Okay. The average time a gas particle spends between one collision and the next is called a mean free time. Okay. I'm still not sure why this matters, but let's keep reading. In general, mean free time decreases as the volume decreases. Okay, that has something to do with the passage, so I am going to underline that. It's probably important. Mean free time decreases as sample's volume decreases. Okay, so basically, the smaller the volume, the shorter the free time will be. Okay, based on table 1, the mean free time would be least for a sample of which gas at which pressure. Okay, free time would be least. That little chunk there tells me free time is least for the smallest volume. So basically, I'm trying to find here which one has the smallest volume. Okay, that's going to take way too long for me to type. I'm looking for the smallest volume, basically. Okay, let's go through all of these and figure out which one has the smallest volume. All right, helium at 0.5. Helium at 0.5 is 44.825, right? Oxygen at 0.5. Oxygen is 44.773. That one's a little smaller, so far that's our winner. Remember, we're looking for the smallest volume because that will also have the smallest free time. All right, so we've got that our winner so far. Helium at 100. All right, helium at 100, that's 0.2. Ooh, that's a lot smaller. So far that's our winner. And then last one, oxygen at 100. Oxygen at 100, That's 0.198. That would be our winner there. So that one is definitely the smallest. 5 should be D. Okay. All right, and then let's see if 6 is about table 1. 6 is table 2. So we'll deal with that later. All right, I've done all the table 1 questions. Now I will move on to table 2. Number 2 asks about table 2. 2, consider the molar volumes of helium, argon, hydrogen, and nitrogen listed in table 2 at 323 Kelvin. All right, so we're looking at 323 Kelvin. We care about the second row. Okay, and again, write all over your tables. What is the order of these gases from the gas having the smallest volume to the gas having the largest volume? So they're just asking us to put these in order from small volume to large volume. Okay. All right. If you're crunched for time, I would not try to put all of these in order 1, 2, 3, 4. I would just try to figure, okay, which one's the smallest? Which one's the second smallest? That tells me what the answer is. You can move quickly. Okay, so which one has the smallest volume at 323 Kelvin? Looking through this row, it looks like it's going to be argon. Nope, it looks like it's oxygen, but oxygen is not an option. Okay, see, oxygen's not listed. So argon is the smallest. Okay, so we know it's either going to be F or G. All right, which one's the second smallest? Is it helium or nitrogen? Helium's 26.504. Nitrogen's 26.492. So nitrogen's smaller. So our answer should be G for that one. I don't need to go through the next two because I already got these two. If you're doing great on time, check your answer, sure. But otherwise, we're trying to be efficient. All right, we'll save 3 for last because it asked about both tables. Save comparison for last. Number 4 asks about table 2. An ideal gas has a molar volume of 63.429 liters at 1 atmosphere and 773 Kelvin. All right, I'm going to use red. We haven't used red yet. Okay, so we're looking at 773 Kelvin. I'm going to highlight this whole row so we know we're looking at this row. Okay, and it has a volume of 63 at 1 atmosphere. This whole thing's at 1 atmosphere. So it has a volume of 63.429. Okay, these are all about that. How many of the gases listed have a smaller volume than this gas? So how many of these are smaller than 63.429? All right. That one is not smaller. That one's bigger. 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 So none of these. So your answer is 0. None of them are smaller than 63.429 at that temperature. So your answer for number 4 should be F. All right. And 5, does 5 ask about just table 2? It does. Let's do just table 2, number 6. Sorry, I misspoke. All right, 6, consider 2 separate 1 mole samples of oxygen, each at a pressure of 1 atmosphere. Okay, cool. This whole table is at 1 atmosphere. And we're asking about oxygen. So I'm going to be paying attention to this last row here. Okay. One sample has a volume of 18, and the other sample has a volume of 63. I'm going to use a different color. Let's use blue. All right, we were looking at 18, and we're looking at 63. Okay. Based on table 2, the average kinetic energy, ooh, where'd they get that, of the oxygen is greater at which sample? Okay. Now, for science ACT, you really don't have to know a lot of science information. Every once in a while, they'll throw some kind of background knowledge in. Here they did. You have to know what kinetic energy is. Kinetic energy is energy of movement. Okay. Now, you also need to know molecules move faster the warmer they are, right? They heat up, and when they're in that gaseous stage and they're hot, they're moving really quickly. They have a lot of kinetic energy. So whichever one's warmer is going to be the one with more kinetic energy, more molecules moving quickly. Okay, which one's warmer, 18 or 63? If we look over at temperature, the one that's 63 volume is warmer. It's at 773 Kelvin versus 223 Kelvin. So your answer is going to be the 63. It's going to be either H or J. And J tells us the correct reason why, because it's at a higher temperature. All right, we've answered all of them except number 3. Number 3 asks about both tables, so I saved it for the very end. All right, based on tables 1 and 2, at any given temperature and pressure, the molar volume of which other gas is most similar to oxygen? All right, this one's worded a little weirdly, but basically they're just saying, okay, for any of these pressures, any of these temperatures, anywhere in the table for both tables, which gas was most similar to oxygen? Okay, let's look at oxygen. I'll just start at the beginning. 44.773. Which of these numbers is super close to that? Argon is. Argon's just 44.774. It's very close. Okay, is argon similar for these other numbers? It is. All right, let's check the second table, just make sure we're on the right track. Oxygen, 18.256, 18.257. That's almost the exact same. And as we go down the column, we see it's almost the exact same. I'd say argon's a great answer for that. Argon and oxygen acted very similarly. So 3 should be B. All right, that is a great tables passage practice. That is all I have for you this week on tables. Thank you for watching and have a great week.